This is a situation we worked on a year or so ago, where we were working in a plant and it had a very nice cooling tower with a very nice control system on it, but it was out the back. The PLC sat in the shed. Nobody ever looked at it. Lots of instrumentation potentially, but it wasn't connected to anything. And when we connected it up and ran it through our performance algorithms, we saw that the cooling tower, the water coming out of it was too hot for the load on the cooling tower and for the ambient conditions pertaining them on the particular day. And the cooling water was being used to drive vacuum in the factory. So the colder, the better. The colder, the deeper the vacuum, the less steam consumption would be in the factory. So when we hooked it up, ran it through our algorithms, figured out it was not meeting performance, we went to investigate it. And as it turned out, it was just a simple balancing issue on the cooling tower. So we rebalanced the flow over the top of the tower. That was stopping short circuiting happening. And we dropped the water temperature coming out by about 4 degrees. So about 2 days work, about £1,000 labor. And the impact was pretty radical or stark. So over this period of time, you can see the cooling water temperature here dropped by about 4 degrees. The vacuum improved significantly. And as a result, the steam consumption on this distillation process dropped from about 1.5 tons to about 1 ton over 3 days or so.